I can present myself.
Yeah.
Thank you for having me here. So my name is Mathieu Jacomy. I'm French, but I'm currently a PhD student at the Talent Lab, so Astra's lab.
No, it's not my lab. It's our lab. It's our lab.
Yeah, your lab, our lab, the lab we belong to,
Yes.
where we work. I had a previous life as a research engineer, notably at the Sciences Po Media Lab in Paris, where I developed some tools. So I'm going to give two lectures, workshops. So this morning it's on HYPHE, which is a web crawler, and I co-designed and coded this tool. And the other one is HYPHE, an older tool on Friday about network analysis. And these two tools work together in the sense that you need network analysis to do something with HYPHE. So I'm going to say HYPHE, but other people will say HYPHE. That's fine. So let's start with addressing what is a web crawler and what is HYPHE. So HYPHE is a free, libre, open source web crawler. So we say free, it's open source software, but we say free, libre, because free is not only in the sense of you don't pay for it, it's also in the sense that the code is open and accessible and people can contribute to. And I say that upfront, and it's very important because, as you will see, you can contribute to the tool even without coding by providing feedback. And there is a system for that, because the tool is hosted on a platform named GitHub, where you can file issues. So issues are a convenient way to talk to the developers and designers of the tool. And you can say, okay, I have this problem in this situation, and then it helps us fix the issues or communicate with you or tell you, well, that's how it was supposed to be, or stuff like that. And it's a web crawler that has been designed for the social sciences. So it has been created in a social science lab. And there are other kinds of crawler that you may know about. The most obvious one is the web crawler used by Google. So of course, when you go to a search engine and you type a query, you get some pages that Google gives you from their index. But to know these pages in the first place, they need to build this index. There is no centralized place where you can know all the pages that exist. And it is this way because on the web, when you create a page, you create it out of nothing, right? You can host it on your own server. So only you know it exists, right? So because of that, Google has to harvest this data, and they use crawlers. So what is a web crawler? We say crawler because it kind of creeps around the pages like a spider on the web. You see the metaphor, right? So it's a robot, but it's a software robot. It's a piece of software that follows the hyperlinks and downloads data into a database, right? So first use of the web crawler, building a search engine. And then there is another super famous web crawler, or kind of web crawler, which is a web archiving crawlers. So if you go to Internet Archive to do digital humanities or stuff, or just because you want to see a web page as it was in the past, you can go to Internet Archives. And also some nations have their own Internet Archive. Denmark has one. France has 1.5. So sometimes you have one actor, sometimes you have several actors, sometimes more than two, and also sometimes they harvest everything, sometimes they don't. But in any case, they use web crawlers, and these have the specific ability to be able to harvest the same page on different timestamps at different moments without overwriting on the older versions, right? So it's an archive, so you have the time, you have a version of the page for each time the web crawler went on this page. And HYPHE is not like that. So HYPHE overwrites the previous content. So HYPHE is not an archiving crawler. HYPHE is made to build a corpus. So the central notion of HYPHE is the corpus. That's what we will see in this short presentation. So a few URLs. I'm just going to, so HYPHE has a website, a demo where anyone can tinker with it. That's probably the one we will use today. source code, how to install it, issues. So here is the link where if you want to discuss with the developers and to file some problems you have and provide feedback, and do it because it's good for us. There's a paper describing HYPHE with a poster. But let's take a look at the demo super quick, just so that you know what it looks like. So it works like a web page. It's not like a software you install. And actually HYPHE has two parts, one that runs on a server and one that you see from your browser. So here I am in Google Chrome, or you could use Firefox or any browser. Connect to a certain URL, the URL of the demo here. And then you have a list of corpora. So I'm going to pick one that I had made before. It's about jazz. It's just kind of random stuff I have used. And so you have a page where you can see the activity of the crawler right now. You can see the list of web entities, which are the websites harvested by the crawler. I will explain what it is. And you can see a network of your pages. So these are the web pages I have found about jazz, stuff like that. So we will dig into how HYPHE works, but just so that you know. So it works like a web page where you create a corpus or project, if you prefer. You do your work here. You download a list of websites or a network. And that's it. So it's all about the web. And one interesting thing about the web is that it was born, it has no center, right? It's not a centralized object. And it was born in the wild, if you want. And we didn't even know what shape it has. So if you look at how the internet and the web were depicted in academic papers, they use all these metaphors. One of them is the cloud, but it's not the only one. You have the web, of course, you have other shapes. And basically, we didn't know even how to represent the web, but more seriously, we don't even know what the topology of the web was. So we didn't know. Now we have better knowledge about that. So that's why web crawlers were created in the first place. So the main question is, how is this network of web pages linked by hyperlinks? You know, when you click on a link, you go to another page. What's the structure of that? And the first effort to guess the structure of the web was this one, the bow tie. So 2000, so 20 years ago. And it's not so long ago in terms of academic life, right? We have this picture that looks like a bow tie. And basically, they used the very simple crawlers. You have to remember that 20 years ago, computers were not like they are now. We had less computer power and stuff like that. So they were very simple. They were just randomly following the links, and then a huge computer was comparing all these paths. And they found that you have basically 4 parts in the web. 4 quarters, if you want. The main quarter is the strongly connected component. The concept comes from graph theory. Whatever about it, that's why they call it SCC. But basically, it's like many web pages that are super connected together, right? So it's the core of the web, if you want. But that's not the only part of the web, of course. So the 2 other parts are on the left and the right, what they call the in and what they call the out. So the in is pages that point to the core but are not pointed by them. And the out is pages that are pointed to, are cited by the core, but don't cite the core. And you have basically kind of a life cycle of a web page on the web. So when you create a web page, no one knows it exists. So it has no inbound links. So it's in the in, but it has links to other parts of the web. And then it becomes cited when it becomes known, and it goes into the core. And when it gets super old, and all the pages it points to have disappeared, but it may still be referenced. It's in the out. That's one of the possible interpretations of that. And the last quarter is the rest. So you have pages pointed to the out, but that are not the core. You have tendrils, so like mini structure that get out of or go into some parts of this landscape. and tubes that go from the in to the out without going through the strongly connected component. And maybe the most important part of all, they cannot find, by definition, disconnected components because they are disconnected, so no path goes to or from there. But they can't know that they can't prove that they don't exist. So we have to be aware that these disconnected components might exist, and of course, so that's why they drew them. Of course, it's important to us because not everyone wants to be visible on the web. So one of the reasons why we would use a web crawler is also to investigate kinds of contents that don't want to be inside Google, don't want to be found, right? A more recent, although not so recent, other representation of the web, and it's the internet map. So basically, they picked the 10,000 most visited websites according to Alexa. Is there a date? So, yeah, end of 2011, so 8 years ago. So it's an old, super old version of the web. And 10,000 is not so many websites if you think of it, but it still provides an idea of the kind of proportions in the web. I think that the size of the round represents the number of visitors in the website. So because we are in Aalborg University, let's search if AU is in the 10,000s, and it is. But even though AU is a huge website compared to most other smaller websites like a lab or personal blog, a Twitter account or whatever, it's still super small compared to bigger websites in terms of visitors. I don't know. Let's unzoom a little bit. techguy.org, UVA, the University of Amsterdam, which is kind of close to us, but you see it's a little bit bigger. But even bigger websites on this scale are small compared to MySpace or Wikipedia, right? So, yes, this is where we are. From that, you can, and it's an important message, have an idea of the huge imbalance, disproportion of the web in terms of who is. It's like fame, right? The Pope is fame. Notoriety between people. What I mean is the Pope can be known by, I don't know, a third of the world population, like literal billions of individuals. But you can also be famous as a researcher if, I don't know, 100 people know about your work in some narrow field. So how many orders of magnitudes are there? Many. So it's a little bit the same on the web. The big and the small are separated by many, many orders of magnitude, right? And this creates a lot of specific issues when you want to crawl the web.
Can I ask a question?
Just after?
Okay.
If you...
Yeah, it was just a question to the picture.
Okay, go ahead then.
What's the significance of the colors?
What? So the colors are the country according to the top level domain. So .uk would be the UK, right? So it does, of course, some might be misattributed in that sense. And you can already see that so the web is already divided by language. And above that, or beyond that, some countries have a specific interest to get separated from the rest, and in particular China. So the big yellow blob here on the bottom left is the Chinese web. But on the bottom right we have a purple one, which is the Japanese web. The Japanese web is not separated because they don't want the Japanese web to be separated from the English-speaking web, which is not the case, but the language makes them separate. Well, for China it's both actually. So the language is a barrier, but also they tend to have their own separated web. Also, just about words, because I forgot to mention that, but it's important. The web is whatever you access through your browser, but the internet is also other things than the web, even though the web tends to eat the other protocols, so that's confusing. But mail, voice over IP, peer-to-peer stuff like that is internet stuff, but it's not the web, right? So this is the web only, and the web crawler is for the web. It doesn't download emails or stuff like that. You're welcome. Another super famous network that comes from the web is the blogosphere of the US election in 2004. So you have the Democrats and the Republicans. And this picture in particular from the paper by Lada Adamik and Natalie Glantz is super important. It's also featured, for instance, in the seminal paper by Lezer et al. On computational social science, right? So you might call that the most famous graph, maybe, the most famous network in science. And it's famous because we see clusters, right? These two balls of different colors, and it tells us, or it seems to tell us, that there is a huge divide between the Republicans and the Democrats. How visible is that? Okay, that's an actual question, and I'm not going to address that today, but later on, and when we talk about networks. But one important aspect of that network is that it's not the whole web, it's just a subcorpus. So the internet map we have seen just before was trying to get a representation of the web by just picking the most visible websites. But this has a different way to cut the web into a subcorpus. It has manually picked blogs that were influent on the political scene at the time, right? So it's a completely different way to delineate a corpus. And another example that has been done with HYPHE, actually. So this is how many websites are there? I don't have the figure here. So it's many websites about climate change. I think in French and or in English, so international institutions, but also some French actors. And they have been manually categorized by librarians with a researcher. So we have, we had a very precise process for tagging these websites according to different criteria. And one of them is, what do they state about the anthropogenic cause of climate change? So what do they say about the fact that climate change has been caused by the human being? And they may say nothing. They may say, I don't know. They may say, yes, it's the human species who did that. Or they may say, no, it's not the human species, right? And so in red, we have the one who were saying, no, it's not the human being. In green, the one that say it is. And then the other colors, but they are a minority. They say something else. And as you can see, we can see different things. But one of the things that a lot of climato-skeptics are present here, but we also coded climato-skepticism in terms of, do they deny climate change? Do they deny its existence? And this is almost not present. So we realized that being climato-skeptic at the time, like a few years ago, is not about denying the existence of climate change, like Trump does, for instance. It's about denying that it's caused by the human being. But in this kind of weakest form, it's also hugely present. And we were surprised that it's present in a coherent space, right? Because you could have like the red one mixed with the green one. So it would say that you don't link to people who think like you. But of course, and this is known as homophily or assortativity, you link to people who agree with you. So there is a space that is climato-skeptic and a space that is scientific. And we were surprised because we expected the blogs to be leaning towards the activist behavior that would promote, try to raise awareness about climate change and stuff like that. And it turns out that the blogs are mostly climato-skeptics. So this is the finding we had from analyzing the websites we harvested with HYPHE. And yeah, so HYPHE helped us find the corpus and harvest the hyperlinks. And then we went to categorize them. So the categorization task has been done without HYPHE manually, right, with other means. So the role of HYPHE here is to help you determine which website deserve to be inside your corpus or not by looking at their content, but also by looking at their links. So the process is like that. You need to start with starting points, so websites that are already in your corpus, that you have found manually, that you have asked experts to give you their bookmarks or what they know about the field. So you need to start with something. And then HYPHE can harvest these websites, find their hyperlinks, and then find more websites because they are cited by your starting point. Then you can take a look at that aspect of the corpus. You can pick the new websites that have been found to tell if you want them or not. And then you can validate your corpus according to certain criteria that I'm going to explain later. So the important part here is that harvesting, monitoring, and curating your entities is an iterative process. You will do that again and again. Okay? So step by step, you expand your corpus. And there are actually even more loops that can happen in this process. So once again, it's iterative by design. That's the nature of the task. You know, research is iterative. So here you have a diagram that comes from Ben Fry. It's, according to him, the chain of data mining. But you can see that he features 4 loops that can happen from acquisition, parsing, filtering, mining, representing your data, refining, and interacting. And HYPHE kinds of covers all of that. So it may happen that you have to restart your corpus entirely because your starting assumptions turn out false, stuff like that. Okay, so this is for the HYPHE what's a web crawler part, right?